Hi everyone, lesson 106, solving radical equations. So we've done some work with radical equations. This lesson we want to get rid of the radical by undoing the square root. And you undo a square root by squaring both sides. So let's look at the first example. Solve simple radical equations. So I have the square root of 4x equals 12. I cannot do anything with 4x until I get rid of the radical symbol. And to undo the radical symbol, I need to square that side. That gives me 4x. But whatever I do on one side, I must do also on the other. So I need to square 112, which will give me 144. Now I can get x by itself by dividing by 4 on both sides. And when I do that, 144 divided by 4, 4 goes into 14 3 times, 24 goes into 24 6 times. So my answer, x equaling 36. Let's take a look at the next example. I need to get rid of the radicals, so I'm going to square. Whatever I do on one side, I must do on the other. So now I have x plus 2 equals 144. To get x by itself, I need to subtract 2 on both sides. And I get x equaling 142 as my answer. And the last example on this page, we have a radical. We need to undo that by squaring that side. That means I got to square the 8. So now I have x over 2 minus 6 equals 64. To get x over 2 by itself, I need to add 6 to both sides. And I have x over 2 equals 70. To get x completely by itself, I need to multiply by 2. Whatever I do on one side, I do on the other. That gives us x equaling 140. These next 6, if you need to see another one or practice another one, here are 6 more examples you can do yourself. Example 2a, solve by isolating the square root. So here you can do a step before you square both sides. So let's look at the first example. Square root of 8x plus 8 equals 15. I need to subtract 8 on both sides. When I do that, I have the square root of x equaling a positive 7. Now to undo a square root, I need to square both sides. That gives us x equaling 49 as my answer. The next one, 3 times the square root of x equals 21. To isolate the square root, I need to divide by 3. So I divide by 3. I end up with square root of x equals 7. I need to get rid of the radical by squaring both sides. That gives us x equaling, again, 49. And the last example, here I'm dividing by 2. I want to get the absolute value, the square root by itself, so I'm going to multiply by 2. Whatever I do on one side, I must do on the other. So I have the square root of x equaling 36. To get rid of the radical, I need to square both sides. Whatever I do, so it's 36 squared will give me 1,296. That would be your answer for this example. We'll do one more of these for practice. Let's do the one on the upper right. So 4 times absolute the square root of x equals 24. To get the square root of x by itself, I divide by 4. That gives me square root of x equals 6. To undo a square root, I square both sides. So x equals 36. These other 5 problems you may do yourself for extra practice. Example 3, solve with square roots on both sides. So we need to have a square root on both sides of the equal sign. In this example, they're both on the same side, so I need to get one of them to the other side. So I'm going to add the square root of 2x to both sides. That gives us the square root of x plus 6 equals the square root of 2x. Now to get rid of square roots, I need to square both sides. That gives us x plus 6 equals 2x. Now to solve for x, I need to get the x's to one side. So I'm going to subtract 1x. On both sides, I have x equaling 6. And that would be my solution. Next one, let's do the one on the left. Since the square roots are both sides of the equal sign, I can now just square both sides to remove the radical. So now I have x plus 6 equals 2x plus 4. Now I want to make sure my x is positive, so I'm just going to subtract an x on both sides. That means I don't want this plus 4 on the right. I got to subtract 4 on both sides. And that gives me 2 equaling x, which would be my answer. Do one more. This side. Square both sides, not square both sides yet. We need to, although you could square both sides, and just to prove that we could do that, if I squared this and squared this, both of these radicals, this would still be 0. This would be 2x minus, and then this would be x plus 2. If I combine like terms here, I end up with 2 minus x equals 0. If I want to get x by itself, I'm just going to add x to both sides, and you have x equaling positive 2. Now, if we went the other way like we were doing before, let me erase this, and we can see if we get the same answer. If I add the square root of 2x to both sides, now you have the square root of x plus 2 equals the square root of 2x. To get rid of the radicals, I square both sides. You end up with x plus 2 equals 2x. Again, I can subtract an x on both sides, and I end up with x equaling 2. So either way, as long as you're following the correct rules, you can still get the same answer. You may do these next two yourself for extra practice. Example 4, determining extraneous solutions. Remember, extraneous solutions means your answer that you could get from a derived or a simplified form of the original problem does not work in the original. So we would say that is not a solution, it's extraneous, and the other answer is the solution, or you could have no solution. Just to clarify with this, when you find a square root of a positive number, you're only going to be using the positive root. So when you find a square root, you can have two roots, a positive and negative. We're only using the positive root. Keep that in mind as we solve these. So here I have square root of 7x plus 15 equals x plus 1. I need to get rid of this radical, so I'm going to square this side. So that gives me 7x plus 15 equals this side. I have to square this side as well. So if I use FOIL, x times x is x squared. 1x plus 1x is 2x. And 1 times 1 is 1. So that's what I have here. Now I want to make this a trinomial equal to 0. So I'm going to subtract 7x, subtract 15 on both sides. So now I have 0 equaling x squared minus 5x minus 14. And I can factor that trinomial and make them both equal to 0. So x minus 7 and x plus 2. If they both equal 0, I have an answer of x can equal a positive 7 and x can equal a negative 2. Now I have to check, does any of them make it extraneous? So now if I put each of these answers in for x, will it give me them, make both sides equal to each other? So if I put a 7 in for x, 7 times 7 is 49. 49 plus 15 is 64. The square root of 64 is 8. The other side, let's put a 7 in for x. 7 plus 1 is 8. So x does equal 7. What if we put a negative 2 in for x? 7 times a negative 2 is a negative 14. Negative 14 plus 15 is a positive 1. The square root of a positive 1 is 1. If I put a negative 2 plus 1 equals a negative 1. 1 does not equal a negative 1. So this is extraneous. So we do not include negative 2 in our answer. So the only answer we can have is x equaling 7. Let's look at another example. Here we need to get the square root by itself, so I need to subtract 6 on both sides. So now I have the square root of x equaling negative 9. To undo a square root, I find the square of it. So that gives me x. Square this side gives me 81. If I check to see, does 81 work in here? The square root of 81 is 9, because remember, I can only use the positive root. 9 plus 6 does not equal a negative 3. So this is no solution. We'll do one more, and then I'll have you do the other one yourself. So let's do this. Let's do the second one here. I want to get rid of the radical, so I need to square it. I need to square this side. So I have x minus 2 equals. Square this side, x times x is x squared. Negative 4x plus a negative 4x is a negative 8x. Negative 4 times a negative 4 is a positive 16. So now I get everything to one side equal to 0, so I subtract x, add 2. Subtract 1x, add 2. This gives us 0 equals x squared minus 9x plus 18. I need to factor this. This will give me, well, let's see, this would be a negative 6 and a negative 3. Because negative 6 times negative 3 is positive 18. Negative 6 plus a negative 3 gives you a negative 9. If I make both of these equal to 0, x equals a positive 6 and an x can equal a positive 3. I have to check, does any of them not work in the original? So if I put a 6 in here, 6 minus 2 is a square root of 6 minus 2 equals 4. So the side is 4. If I take 6 minus 4, does this, so the square root of 4 is 2. So this side is 2. 6 minus 4 is 2, so I know 6 is a solution. What about putting a 3 in? So if I have the square root of 3 minus 2, this will give us square root of 1, which is 1. The other side, if I put a 3 in, 3 minus 4 gives us a negative 1. 1 does not equal negative 1, so this 3 is extraneous. The only answer is x equals 6. You may do the one on the left for extra practice. And the application 5A. An architect is designing a performance center. If the area of the center is 30 square decameters, what is the area of the gallery? So this whole thing, this whole center has an area of 30. So I can say that equals 30. How do I find area of a big rectangle? It's the length times the width. So if I do that, I have the square root of x times the square root, or find the square root of x plus 6 minus the square root of x. You can see here in this set of parentheses, square root of x minus the square root of x is 0. So all I have left is 6 times the square root of x. This has to equal 30. So now to get the square root by itself, I divide by 6. Divide by 6. So now I have the square root of x equals 5. We learned that to undo a square root, you square both sides. So now x equals 25. So if x equals 25, I can put 25 in for x to find the area of the gallery. So the gallery, this side is the square root of x. This part right here is 6 minus the square root of x. So now if I put this as, if I put 25 in for x, the square root of 25 is 5. We just said x equals, square root of x equals 5. If I put a 5 here, this gives me 1. This gives me 5. So 5 times 1 gives me 5 square decameters. And the last one, I'll get you started with this one. A breakfast nook has a planter along one side. The entire area of the nook is 42 square yards. What is the area of the planter? So this is the length of the whole area. The area of, or the length or the width is square root of x. So we need to find out what is the area of the planter. So in order to solve this one, we will have square root of x times square root of x plus 7 minus the square root of x. All this has to equal 42. So now if I were to do this one, the x square root of x is canceled out here, so I just have 7 times the square root of x equals 42. To find this one, divide by 7. Divide by 7. The square root of x equals 6. So we don't even have to find out, we don't have to square both sides, because if the square root of x is 6, I can put 6 in for wherever I see a square root of x. So this is 6, this is 6. So to find the area of the planter, I have 7 minus 6, which is 7 minus 6 equals 1. And I need to multiply that by 6. 1 times 6 will give us 6 square yards. And that would be your area of the planter. Your assignment for next time, lesson 106, numbers 1, 4 through 7, 10 through 11, 14, 18, and 22.